Today we are going to continue with hyperbolas. This time we're going to talk about getting them in a standard form into that graphing setup where we can find our A, B, and C to find the important points. What happens when we move it out of standard form like this is we're going to have some transformations we need to associate with, meaning we're going to need to complete the square and work from there. So first step of that is we get this mess equal to 0. We need to group the y stuff together and the x stuff together and factor. So we're going to have 9y squared minus 54y. That's going to be one set that I'll have to complete the square on. Minus 5x squared minus 20x. And this constant, I'm going to move it to the other side because I don't want to deal with that until the end. Minus 16. So these are the things that I'm going to have to complete the square with. So to start that, I need to factor this. I need to get ones, positive ones, in front of both the squared terms. So that means I need to factor out this 9. And I get y squared minus 6y. And this is the one that'll be tricky with hyperbolas. I need to factor out that minus 5. That is going to leave me x squared. But because I'm factoring out a negative, it's going to change the sign inside here of this negative 20x to a positive 4x. Just be really, really cautious when you're going to do that factoring. Because now from here, this is what I need to, these two things, I'm going to have to draw the box with the extra box and complete the square. And I'm going to do that on the next slide. So we've got this thing set up to where we can complete the square and move everything around to find A, B, and C. So here we are. So let's complete the square. I'm going to do our box with our extra box factoring. And that means y squared's here. Split this in half. We get negative 3y, and then negative 3 times negative 3 is positive 9. And then to balance that, we put a negative 9 here. And then we factor this. These have a negative 3 in common. That has a y, that has a y, and a negative 3. So I have 9y minus 3, I forgot the big bracket, I'm sorry, y minus 3 squared, because that's what we want to have happen. We want the same thing here and here, and then minus 9 here. I'm going to draw the box with the extra box and factor this one. Same way I just did the last one. X squared, we're going to split the 4 in half. We get 2x and 2x. And then 2 times 2 is positive 4. Means I balance it with a negative 4. And this is going to have a positive 2 in common, and x, and a positive 2. Don't forget about your negative 5. Negative 5, big bracket, times x plus 2 squared minus 4. And then don't forget over here, we're still equal to negative 16. So now we're at the step where we can distribute and start moving everything around, because we'll eventually need to get this number out here, this negative 16 equal to 1, so we can find our A, B, and C values to find our points. So let's distribute the 9. So we're going to get 9y minus 3 squared, and 9 times 9, that's 81, minus 5 times x plus 2 squared. Negative 5 times negative 4 is positive 20, equal to negative 16. So now from this step, we're going to add this 81 minus this 20, which we need to go minus 20 and plus 81, because those cancel there. So we end up with 9y minus 3 squared minus 5x plus 2 squared, and that's going to be, if we plug this through, we should get 45. Now, I don't want this 45 here, I want it to be 1. So we're going to divide everything by 45. So that'll give me 1 out here. And this stuff's going to remain on the top because these are going to have common factors. At least for the ones that we are doing, this is still going to be the minus. 5 and 45, that means there's a 9 down here. And this is going to be a 5 down here because 9 divided by 45 is 1/5. 5 divided by 45 is 1/9. There we are, we're in graphing form. And there's a lot of stuff that we can determine from this one right off the bat. So, forget about these parts for a second. We know that this thing opens on the y. It opens on the y-axis because the y fraction is positive. And that's important because when we find our focus and our vertices, we know that they'll start with y values before we apply the transformations to them. Because our focuses are here, and our vertices are here. So a squared is always with positive fraction, b squared is always with the negative fraction, and we use Pythagorean theorem to find c for this one. So a squared is equal to 5. So that means a is the square root of 5. B squared is equal to 9, so therefore b is 3. C squared is a squared plus b squared. So that's 9 plus 5. So that means c is going to be the square root of 14. So there's all the points that we need to find. There's all the values we need to find our points and our asymptotes, and then we'll deal with these transformations, okay? So let's list them right here. Excuse me. So our transformations, the y having a minus 3 with it means that this thing is going to go up by 3, which means we can take y values and add 3 to them. Plus 2 means that we're going to go down by 2, so we can take the x values of the points and simply minus 2 from them after we find them. So focus, vertices, and then we'll deal with asymptotes. So focus and vertices. So focus always comes from the c, which was that square root of 14, and it's going to be a y value to start because it opens on the y. Vertices come from a, and a is the square root of 5. And it's going to be a y value. These always start as y equals plus or minus whatever our slope is times x, and our slope. So a was associated with y, b was associated with x, so that means it's root 5 over 3. Which we can leave just like that. Let's deal with those transformations now. So the focus and the vertice, we can simply go through and add these to it. So let's start with our x's. Our x's move down by 2. So we're going to take 0 and we're going to minus 2 from it both times. It's pretty easy. We just get negative 2. Now we're going to take these numbers here, this plus or minus the square root of 14 and plus or minus the square root of 5. And those y's should go up by 3. So we're going to add 3 to both of those. Now remember, what we're doing here is we're really representing 2 points, whether we take this square root to be positive or negative and then add 3 to it. But we're just representing it with one coordinate. Now with the asymptote's not too bad. Whatever we see inside the parentheses with the x and the y's over here is what this needs to gain. So the y is going to be minus 3. That's equal to plus or minus the square root of 5 over 3, and then the x had a plus 2. That's x plus 2. And that's what we are looking for. So our answers are right here. Here's our 2 points, and here's our equation of our shifted line. This stuff is tough. Just make sure you stick with it and practice. Let me know if you need help.